Now we continue with the Lewis dot diagrams. Again, Lewis dot diagrams are putting dots around the element symbol. So we're asked to do francium 87, and we need to write the symbol francium. And then this side is the electrons that are in the s sublevel. This is a p side, a p orbital, and a p orbital. So we're just doing the valence electrons. So first we have to find francium on the periodic table of elements. We look over here. Francium is right down here. It's at the very bottom left of the table. It is in the first column of the periodic table in the s block. They only have one electron and an s. They're Roman 1, so they only get one dot on the s side. When I do these, I always like to color coordinate my dots. I do the s side kind of in an orangish color, only because that's the s side, and if you look on the periodic table, that column, the s block part of the table is sort of that orangish color right here as well. This is the s block right here on this side of the table. And if you look, the main block families, these are the Roman numerals on the top. The main block's the s block, and it's over here, it's the p block. These Roman numerals on this top row give you the number of valence electrons. Those are the number of electrons in the s and the p sublevels. These Roman numerals, as we've said several times, are not giving you valence electrons. For most of those families, they're trying to tell you something about how many electrons are in the s and the d. In the case of having 3 Roman 8s in a row, they're trying to tell you that cobalt and nickel down here have similar properties to iron. That's why they gave them all Roman 3s. The next one, we're asked to do a dot diagram. Astatine, number 85. We've got to hunt that one down on the periodic table. I'm going to look down here. It should be all the way down on the far right near the corner. Here's astatine right here. AT number 85. It's in the halogen family. I'm seeing right here that they should have 2 in the S, and it looks like 5 in the P. Astatine has a Roman 7. Its diagram should be 2 in the S, 5 in the P. It should look just like this when we're done. So let's go ahead and do that. So here's the 2 in the S, and then when we go to put them in the P, you go 1, 2, 3, and then we can start doubling up 4, 5. So 1 go on each side in accordance with Hund's rule, which says each orbital of a sublevel such as the P, D, or F, sublevels that have multiple orbitals in them, you put 1 in each orbital, then we begin doubling it up. So we've got 2 in the S, 5 in the P. Let's double check the periodic table to see if that's what it should look like. 2 in the S, 5 in the P. Should look just like it. It's in family Roman 7. And once again, it's right down here. 2 in the S and 5 in the P. We don't dot the F and Ds because those are inner levels. Astatine actually has electrons in the 4F and the 5D. All right, what's our next one that we are supposed to do? Germanium, number 32. Let's find it on the periodic table of elements. Here's germanium right here. Right there, number 32. It should have 2 in the S and 2 in the P. It is a Roman 4. Its dot diagram should look just like this one. 2 on that side, 1 on each underneath. So let's go ahead and do that. All right, here's germanium, and I'm going to put 2 on the S side. And I'm going to go ahead and put 2 on the P, 1 on each on the P sides here. There's 1 P, and there's my second P. If I had a third P, it would go up here, and then I can start doubling them up. So there's 4 total electrons, 2 in the S, 2 in the P. Let's double check once again to be sure I did that right. Here's germanium. Right down here is germanium. 2 in the S, 2 in the P, for a total of 4 valence electrons, looking just like this one here. The next one that we are doing, copper. Now, this is a transition metal. I'm glad we have copper, a transition metal. Here's copper right here. I believe it's number 29. There's copper. Above it, it has S1D10. There are nothing written in the P's because the P's don't get filled until after the D. So I only need one dot, one for the S. We don't dot the ones on the D. That's the 3D. Copper's S is on the 4. That's its outermost electron. So it has 1 in the 4s and it has 10 in the 3D. Its dot diagram should look like just like this above here. One valence electron. What's important to understand, it does have one valence electron, so that valence electron would be the first one that gets involved in a chemical reaction. However, once that electron is involved in the chemical reaction, then the electrons in the D can come into play. So that's like something that distinguishes how we dot an atom versus how we would dot some of these elements in here when they're getting involved in chemical reactions and forming molecules or getting involved in forming compounds. Because copper can have some of its D, really one of its D electrons engage in a chemical reaction as well. So we don't dot the D's because those are 3Ds. Now, if you're doing a molecule or something that has some of these metals in here, then you might have to dot the D's. But that's for a discussion further on down the line, several units from the one we are now in. The next one that we're supposed to do is helium. This should be a very easy one. Helium's number 2, so it only has 2 electrons. So it can only have 2 total electrons, and we would know that they would both be in the 1s. And the only reason we're doing helium is to show you that helium is a noble gas. Helium's dot diagram is actually already on here. Just to remind you that helium is an S2. The rest of the noble gases underneath it are S2P6s. They have 2 in the S6 and the P for a total of 8. But the first energy level only has room for 2 electrons. It has one S sublevel made up of 1 orbital. Very similar to the reason why there's only 2 elements on the first energy level, shell, period, row of the periodic table of elements. So helium gets 2 dots, and we are finished with this assignment. If you have any questions on the dot diagramming, don't hesitate to contact me. If you have questions on any of this, do not hesitate to contact me. This is important stuff to understand in this unit. We will be using dot diagrams really in almost every unit the rest of the way, or at least in a lot of the units the rest of the way. Thank you very much.